Looking at this next example, it says, given point Q is outside a circle O, two tangents C and D make contact with the circle O. And it says OC, vector OC is lowercase c, vector OD is lowercase d, and vector OQ is lowercase q. Question A. Show tangent QC and QD subtend equal angles. And B. Show that QC equals to QD. So before we start any of these questions over here, we need to understand what is the question really asking us. So let's just draw this over here. So let's just say we have circle circle O, with O being the center of the circle. It says given point Q is outside a circle O. So let's just say the point is somewhere over here. This is point Q. Two tangent C and D make contact with O. So tangent 1, this can be C. Let's just connect that with O. And tangent, this is C. Sorry, draw that a little bit bigger. C, and this is D over here. My bad. Not the best with drawings. Yeah, so this is D over here. Show tangent QC and QD subtend equal angles. So QC and let's also say this is OC over here. Vector C, and this is OD. Vector D. And this is OQ. OQ over here. QC and QD subtend equal angles. First thing I will do to this is find this angle over here. Obviously we know this is going to be 90 degrees. So the dot product of QC is C minus Q, vector C minus Q dot vector C. In this case it's going to be 0. Since this is the center of the circle, OC and OD is going to be the radius. So let OC and OD be equal to R, because the center of the circle, we get that relationship. C minus Q. Next step, this then becomes C dot Q equals to C dot C in this case. But we already know what OC is C, which is going to be R squared. Similarly, do the same thing for this over here. We get vector D minus Q dot vector D equals to 0, because we'll take the dot product, and when they're perpendicular equals to 0. Same thing, D dot Q equals to D dot D, which is going to be OD, in this case is R squared. Therefore, since both of these equal to R squared, C dot Q equals to D dot Q over here. So the tangents of these two hence then give us equal answers. Next step, let's do B over here. To do B over here, one thing I will do is we need to consider the length of CQ. So the length of CQ over here. So to find the length of CQ, and we're going to square it, length of CQ would then be Q minus C all squared, which is going to be, in this case, Q minus C dot Q minus C over here. Next step, this becomes Q all squared minus 2 q dot c minus c all squared. But we know this is going to be the same for dq, vector dq, so we can rewrite that as q squared minus 2 q dot d minus d squared over here, the magnitude of d squared, which then at the bottom gives me q minus d all squared. So, sorry, I can rewrite this as lowercase q, and this will be lowercase c in this case. So this then equals to that. Therefore, CQ equals to DQ in this case. So that is how you do example number 2. Now we'll go on to the next example.